So now that we understand what an imaginary number is, we can start talking about complex numbers and how we add and subtract them. So complex number is defined as a plus bi, where you're taking a real number and adding or subtracting an imaginary number to it. And so this whole thing would be a complex number. Okay, so a and b have to be real numbers, and of course I is defined as the square root of -1. So that's the imaginary part, right? So technically, this right here is considered the standard form of a complex number, and they're very, very picky about their standard form. So for example, this right here is a standard form of a complex number. It's very easy in this case to read off what your A and your B are. So A is 5, B is 2. Very clear. Well, sometimes our complex numbers are a little bit more complicated than that. So what if you had -8 plus a -√2 times I? Okay, well, that's great. If you look at this, this is the standard form of our complex number. Very clear to read off the -8 and the -√2 as your A and B. But a lot of times numbers that look like this in standard form actually look like this when we work with them. So a -8 minus I√2. So in that case, you can look at this and still the -8 is the A. But the b, when you have to read off what the b is, first of all, the I is in front of the radical, so you have to look at the √2 here, and this is a minus sign. So you have to think about it as plus a negative, right? So the b would be the -√2. Now, when we are working with complex numbers, and anytime I ask you to leave your answer, you're adding or subtracting or something, you can leave your answer in this form. You don't have to change this to a plus, a negative. The I do want the I in front of the radical. But if they ever ask you to officially put it in standard form, this is what you have to do, right here, up there. Okay? So most problems, I'm okay with this form. Unless they actually ask you to put it in standard form, then you do that one. All right, so when you add and subtract complex numbers, it's just like combining like terms. So if you look at this, a plus bi, and then we're adding c plus di, well, you add the real parts together, so the a and the c get added together, and then you add the imaginary parts, so bi plus di. So here's the a plus c, that's going to give you the real part of your complex number for the solution. And then if you add the b and the d together, that's going to give you the real number associated with the imaginary part of that problem, if that makes sense. So it's the number multiplied to I. There's too many b's in that problem, sorry. Okay, so this makes it look really complicated, but it's actually super easy. All right, so when you look at this, if you take 2 plus 3i and you add 4 minus 5i, you're just going to add the 4 and the 2, and you get 6. And then you add the 3i plus the -5i, and you get the -2i. And I'm not here asking you to put it in standard form. This is perfectly acceptable to leave your answer in. Down here, you're subtracting, so whether you need to distribute that negative sign through, or maybe you can just read it off, but you're doing 8 minus 3, and then you're doing -5i minus 6i. So we get a 5 minus 11i. See, I told you it was super easy. All right, that's it.